let's do a little bit more first derivative test. So we want to find the x-coordinates of the local extrema of the function f of x equals 1/2 x minus sine x on the interval 0 to pi. Right? We don't care about any extrema that are beyond that interval. Right? And notice the brackets, that means including 0 and 2 pi. All right, so, and our justification is our steps right here, all of our work, and most importantly, our interpretation. So, to save a little time, I wrote them up here. Take the derivative is our first step. F prime of x. All right, that used to be an f, there we go. F prime of x equals, so derivative of 1/2 x is 1/2. And the derivative of sine x is cosine x. All right, number 2, we need to take that derivative. There we go, that box is gone. Set the derivative equal to 0. So 0 equals 1/2 minus cosine x. All right, I'm going to add cosine x to both sides. Get rid of the negatives. So cosine x equals 1/2. We'll take the arccos of both sides. So arccos of cosine x equals arccos of 1/2. Arccos and cosine are inverses of one another, and that leaves the x. All right, now we have arccos of 1/2. All right, draw yourself a little coordinate plane, and then ask yourself, where is cosine positive? All right, well, the triangle's got to be either in the first or the fourth quadrants. Right? And that will be in between our interval of 0 to 2 pi. All right, so cosine is the adjacent over the hypotenuse. And this is getting in the way of our interpret, so I'm going to move this up here and move that just a little bit. All right, so that means that the adjacent has to be 1, and the hypotenuse has to be 2. Right? What triangle has 1 and a hypotenuse of 2 as part of its sides? If you weren't sure, I guess you could use Pythagorean theorem and find that the missing side is the square root of 3. All right, so this is a 30, 60, 90 triangle. All right, so we're interested in our 2 angles there. And so 1 goes from here to here. All right, so that's going to be opposite. That angle is opposite square root of 3. All right, square root of 3 is the larger of the 2 legs. So it would be opposite the 60-degree angle, which in radians is pi thirds. All right, and then we're interested, so this was the first one, and then we're interested in this angle that's all the way over here. If I were to go the whole circle, that would be 2 pi. So 2 pi minus, again, this will be pi thirds. So 2 minus pi thirds, that's going to be 5 pi thirds. So that's our 2 solutions there, pi thirds and 5 pi thirds. All right, so x equals, oops, there's my pen. Pi thirds, x equals 5 pi thirds. I've already answered question number 3, but I'll read that to you. Identify any values for which the derivative is undefined. Sine and polynomial functions are differentiable everywhere, so there is nowhere where the derivative is undefined. All right, so nothing to consider except for our 2 critical points. Actually, I'm going to write underneath here. We had this is a critical point. Ooh, I didn't mean to write it right over my number. There we go. This is a critical point, and this is a critical point. On our sign chart, remember they go from least to greatest. All right, so we have the pi thirds and 5 pi thirds, and that's where the derivative is 0. We need to evaluate on either side of those points there. All right, so a good choice would be 0. Another good choice between these two would be pi halves, and then finally 2 pi. All right, all within our interval. All right, so, and we look to our derivative, which is 1/2 minus cosine x. All right, if I plug in a 0, cosine 0 is 1. 1/2 minus 1 is negative. If I plug in pi halves, cosine pi halves is 0. 1/2 minus 0 is positive. If I plug in 2 pi, Cosine is also 0 at 2 pi. So cosine is also 1 at 2 pi. Try not to cough. 1/2 minus 1 is going to be negative. All right, so now we have our sign chart here. I'm going to take a moment before I start to do the interpretation. Let's just take a look at what we have here, and we should write where our max and mins are. That way when you're writing your interpretation, it's a little easier. You don't have to interpret and write at the same time. You've got your little hints right up there. All right, so let's take a look at pi thirds. We go from negative to positive. That means this is a relative min. Actually, I'm just going to write min. I think we can leave out relative on our little chart here. Min. All right, then we look over at 5 pi thirds. We go from positive to negative. This is a max. All right, that might help you as you're writing. Keep your train of thought. I know it helps me keep my train of thought. All right, so now we're going to do the interpretation. All right, so since f prime of x, make sure you're always specific. Tell if you're talking about f prime or you're talking about just f. All right, so since f prime of x is negative, or changes, excuse me. I'm not talking about increasing, decreasing. Talking about relative max mins. Changes, where's my s? Changes sign from negative to positive at x equals pi thirds. F of x, you want to make sure you reference back to f of x, is that's who's got the, in this case, minimum. F of x is the one with the minimum. F of x has a relative minimum at x equals pi thirds. Since f prime of x changes sign from positive. What happened to my V? Positive to negative. I can't remember which letters I wrote already. Negative at 5 pi thirds. F of x has a relative maximum at 5 pi thirds. And there you go. All right, this is going to be your interpretation for max and mins. Just what I put up there. Follow my example exactly. Follow word for word. That's fine, right? This isn't called, come up with your own explanation. We're short, we're right to the point, and we're not vague, we're complete. All right? So, this one has been done. All right? We have figured out where our extrema are, and we have justified properly. Let's look at question number 2, or number 6. All right, so find the x-coordinates of the local extrema of the function g of x equals 6x to the 5th plus 33x to the 4th minus 30x cubed plus 100. Right, justify. All right, again, this is a polynomial function. Notice it just says x-coordinates. What if it asks us for the y-coordinates too? We just plug the x-coordinates back into the original function. All right, our first step to find out where these local extrema are is to take the derivative. So back when you were, by the way, in algebra 2, and we would graph polynomial functions and we would find our turning points, remember I said we would have to estimate them, and we knew they were between x-intercepts. And I told my class, those are the only tools you got, so you're going to have to estimate where they are. When you're in calculus, you can find out where they are exactly. Well, now you're in calculus, and you can find out where our extrema are exactly. All right, so g prime of x is equal to 30x to the 4th plus, say it's going to be 120 plus another 12, 132. 132, did not give myself enough space. I'm crowding this over here. X cubed minus 90x squared, and that's it. Right, because the derivative of 100 would just be 0. Let's see if I can move this over ever so slightly. And then, boy, this goes downhill. Come on. No, I don't want a clone. I don't want a box. I just want you to move. Move, move. Sound like a cow now. No, don't move back to the same spot. Right there. Now get rid of the box. You move over too. You're not special. Move. Aha, there you go. And now we'll just move this over here and this over here, and now we have enough space. Sorry about that. That's as far as I can go. Okay, we've done with taking the derivative, by the way. All right, so it's just all power rule here. Now we want to set the derivative equal to 0 and solve. 0, I'm going to try to write a little bit smaller there, is equal to 30x to the 4th plus 132x cubed minus 90x squared. And these are divisible by 6x squared. I can pull out a 6 out of 30. 132 is divisible by 6, as it would go in 22 times. And so is 90. And that's going to be the greatest common factor, because I'm going to be left with a 22. I'm going to be left with a 5, a 22, and a 15. They don't have anything in common altogether anyway. So we have 0 equals 6x squared. And then we have 5x squared plus 132x minus 90. We're going to, I'm just going to do that. And then we will factor the rest. All right, so, whoops. All right, don't divide the rest of them by. Plus 22x minus 15. I said it was going to be 22 and 15. I decided not to write it. All right, 5 times negative 15 is negative 75. So I got to factor this. So I got 5x squared multiplies to give me negative 75, adds to give me 22, is going to be negative 3 and positive 25. So we got 5x squared minus 3x, your group, plus 22x minus 25x minus 15. Let me get my head back into factoring here. 25x minus 15. My hand is going faster than I'm saying it, and it's writing the wrong things there. It's like, look it up above. All right, so I'm going to pull out an x here, and I have 5x minus 3. Greatest common factor here is a 5. If we divide those by 5, we have 5x minus 3. So factored, this is the repeating 5x minus 3 that we just pulled out. And we would be left with x plus 5 from the other terms. And don't forget the 6x squared. All right, so now we'll set those equal to 0 and solve. If we just move this down a little bit. Oops. That's the only problem with writing things in advance. Sometimes I don't anticipate how much space I actually need. I only need a little teensy bit more. Oh, a y is separated, because I just need to set those equal to 0 and solve. There we go. Good enough. All right. So we got 6x squared is equal to 0. So x equals 0. 5x minus 3 equals 0. X is 3/5. And then x plus 5 is 0. X is negative 5. There we go. All right, so these are all our critical points. They're critical points because f prime of x equals 0. All right, do we have any places where our function is undefined? Well, no, because polynomial functions are differentiable everywhere. So there are no values where the derivative is undefined. So let's go right to the sign chart. All right, our smallest is negative 5. So that's a 0. And then I need to move this down just a little bit. I don't know, maybe I can squeeze that in without moving it down too much. Good enough. All right, and then we have 0. And 0 is a 0. And 3/5 is a 0. So less than negative 5, we'll choose negative 6. Between negative 5 and 0, let's choose negative 1. Between 0 and 3/5, let's choose a half. And between greater than 3/5, let's choose 1. All right, so if I plug back -6, remember I only care about sign here, right? Not the value necessarily. No matter what, 6x squared is going to be a positive number, right? Right, so no matter what, this 6x squared is always positive. So let's not even consider the 6x squared. Let's just look at the 5x minus 3 and the x plus 5. So if I plug in a -6, I'm going to have -33, right? So definitely negative. If I plug in a -6, I'm going to have -1. That's going to give us a positive number. If we plug in a -1, that's going to be -8, still negative. But this will be 4. Now that's positive. If we plug in a 1, 5 minus 3 is positive, and 1 plus 5 is positive, and we decided to skip the 1/2 altogether. Let's go back to the 1/2. All right, so if I plug in a 1/2, 5/2 minus 3, that's going to be a -1/2, so that's negative. If I plug in a 1/2, I'm going to have, where are you? No, I'm going to have a positive number, right? Because I'll have 5 halves, what was it? I'll have 1/2 plus 5, that'd be positive 4.5. So, where's my pen? Here it is. That's going to be positive. All right, so I'm only caring about the sign. All right, and so 6x squared is always positive, and then I just have to decide, is the number less than 3, then I'll have a negative. If it's greater than 3, I'll have a positive. And here, unless I plug in a negative number greater than 5, I'm going to have a positive for x plus 5. So we have our sign chart, and so now we can interpret that sign chart. But before we do that, let's just write whether each point is going to be a max or min, so that when we're going back to write it, we won't forget what we wanted to say. All right, so we have a relative, we go from, wait, did I write the wrong sign in on one of these? That's way too many pluses. I don't think I had that many pluses. I think I lost my train of thought. All right, so -1 was a negative and a positive. That should have been a negative. I don't know why I have a positive in there, right? Because that would be -8 and positive 4. The 1/2, if I plug in 1/2, that's going to be negative, and that's going to be positive. What the heck? Why did I put bit one is a negative? Why did I put a positive there? I'm sure I said it right. Oh, I think I did. But that is a negative, right? Everyone agree? Right, so if I put a negative in there, I've got -1/2, and I've got a positive 5.5. Yeah, I think I was thinking it was negative. I don't know why. But anyway, either way, it's definitely a negative number. All right, so now our sign chart is correct. Boy, it's a good thing I stopped to look at it first before I started writing it. I don't know what I was writing there with my pluses and negatives. Maybe I should have given myself more room so I could put little pluses and negatives in there. All right, so this one is going to be a max because we go from positive to negative. This one is a neither because we don't change signs. And this one we go from negative to positive. This is a min, and that is correct. Interpret our sign chart. Right? So, since f prime of x changes from positive to negative, at x equals -5, f of x has a relative max, I'll put minimum, at x equals -5. Since f prime of x changes signs from negative to positive, at x equals 3/5, f of x has a relative minimum at x equals 3/5 since there is no sign change at x equals 0. 0 is neither a relative max or min. Right, so no, I didn't write in f of x doesn't have a relative max at 0. I guess I could have. Let me look at the sentence and make sure the sentence still sounds good. Since there's no sign change at x equals 0, 0 is neither a relative max or min value for f of x. I like it at the end better, huh? On this particular sentence. All right, so there we've interpreted, and now I have the right signs in my chart. I'll have to listen to my tape. Make sure, did I say negative, positive, and write negative? Or did I say negative and write positive for some strange reason? Probably the second. All right, let's go to do a few more. Let's see if we can kind of finish up here. All right, I think I've got 4 more. See how long it takes us. All right, so we want to find the relative extrema of f of x equals x squared minus 4 to the 2/3. We have a chain rule. So f prime of x equals, we got blop to the 2/3 power. That's going to be 2/3 blop, and then subtract 1 to the negative 1/3. Of course, the blop is x squared minus 4, and we got to take the derivative of the blop, which is 2x. Let's rewrite this. F prime of x equals, in the numerator we have 2 times 2x, so that's 4x. In the denominator, we're going to have the cube, we have 3 times the cube root, almost forgot the little 3 there, of x squared minus 4. And there we go. We'll set our derivative equal to 0. Yeah, that's good enough. So we have 0 equals 4x divided by 3 times the cube root of x squared minus 4. If we were to multiply, actually let's just cross multiply. So we're going to cross multiply. It's easier than me writing the denominator next to both sides because I don't have a whole lot of space next to that 0. So we'll cross multiply and we end up with 4x equals 0 because 0 times anything is 0, which means x equals 0 is a critical point. All right, so this is a critical point. By the way, if you're asked why, so if you needed to justify why a point is a critical point, let's actually put in a justification for why this is a critical point. All right, we've been justifying our relative max and mins. Let's justify this as a critical point. So this is a critical point because actually let's write in because, but we're going to put a symbol in for because. All right, so the symbol for because looks like a triangle of points, but upside down. All right, so it's a critical point because f prime of x is 0. All right, that's why x equals 0 is a critical point. Identify any values for which the derivative is undefined. Notice I don't have anything written here, and that's because now we have a place where our function is undefined. Our derivative is undefined. Right? So f prime of x is undefined when the denominator equals 0. Right? So f prime of x is undefined at, so if we set 3 times the cube root of x squared minus 4 equals 0, and we factor that, so 3 times the cube root of x minus 2, x plus 2, all right, we set that equal to 0. Let's put it over here. All right, so we're going to be 0 when x equals 2. So f prime of x is undefined when x equals 2 and x equals negative 2. All right? So these are, again, critical points. They're critical points because our derivative is undefined. All right? We need to create our sign chart. All right? And we've got negative 2 for undefined. We have 0, and 2 undefined. Right? So now, even though our derivative is undefined, our function is not undefined at negative 2. Right? There's no problems plugging, we have a cube root. So x squared minus 4 to the 2/3 power, that's a cube root. Cube roots are defined everywhere. Their domain is all real numbers. Right? So the functions, f of x is defined for negative 2 and 2. It's the derivative that's not defined for negative 2 and 2. All right, so we're going to plug on either side. Excuse me. Negative 3, negative 1, 1, and 3. All right, and I will make sure I write down the correct sign when I'm plugging in. If I plug in negative 3, I've got 9 minus 4 in the denominator. It's a cube root of 9 minus 4. That's positive. The numerator, however, would be a negative 12. So this is negative. If I plug in a negative 1, numerator's negative, right? This would be a negative 4. If I plug in negative 1, I've got the cube root of negative 3. So that is negative, making that a positive. Move up the words here. I'm losing my negative and positives in the word sign chart. If I plug in a 1, this is a positive. That's still a negative. So I get the exact same thing. If I plug in 3, I've got 12 in the numerator. I've got cube root of 5 in the denominator. That is a positive. There, it helps me to write plus and minus. I don't lose track of what I was saying. All right, so here we can see where our max and mins lie. All right, so negative 2 is a min. 0 is a max. And 2 is a min. All right, and let's write our interpretation. So, since f prime of x changes sign from negative. By the way, there is another way I could write this. I think it maybe takes more words though, and I'll tell it to you. So since f prime of x changes sign, maybe I'll write it on the next one, changes sign from negative to positive at x equals negative 2 and x equals 2, f of x has relative minimums or relative minimum values. I think that sounds better than relative minimums. Relative minimum values at x equals negative 2 and x equals 2. And then since, oops, there's like something on my board here. Since on the outside, since f prime of x changes sign from positive to negative, at x equals 0, f of x has a relative maximum at x equals 0. I could also say, instead of said change a sign from negative to positive, I could say since f prime of x is, and then put a symbol less than 0 for x less than negative 2. Well, I have it in Word. I think I've got it written down somewhere else where I use another explanation. I think it's going to take me more words, however, to write the same thing. Maybe I'll do it on the next one. We'll see how many words it takes me. Or maybe the last one. The last one, I'll write it in a different way. a slightly different way. But I think this one is the most succinct, all right, in terms of being able to explain it. The other one is I could show what the sign is, all right? So it's less than 0 for all x, which ones? So all x less than -3, and f prime of x is greater than 0 for x. Then I'd have to say greater than -1 but less than 0. So it gets a little hairy if I use an interval there, because I can't say just greater than -1. So I tend to like this one better. I think I've probably used it though on some other notes, so we'll run across it. I think this is the most succinct way, because I know it takes me longer if I use interval notation. But just saying change a sign and telling you what sign it changes from, right? Because it's important. If you just say change a sign, that doesn't tell you whether it's a max or min, right? But if you say negative to positive, that tells you it's a min. So I'll just keep this writing because I'm already at 31 minutes. And then in another lesson, I know I've already got it written down, and I'll show it to you, and you'll see it's a little bit more wordy. So you'll probably like this one better anyway. So we have 3 problems. Let's see if we can get it done relatively quickly. That's the other reason I don't want to change the writing at all. Save time. Take the derivative as our first step because we want to find our relative extrema. We have 2 values here. Two equations here. So we're going to do the first one, and then we'll do the second one. They look a lot alike, but they're just a little bit different. Now I could use the product rule, and I've done this one with the product rule, and I will tell you it's a little faster to just distribute and instead just use the power rule. All right, so that would be k to the 2/3. So t of k is k to the 2/3 times 2k minus 1. If we distribute, 2/3 plus 3/3 is 5/3. So t of k is k to the 2k to the 5/3 minus k to the 2/3. It's a lot faster than doing the product rule. So t of k, equals 10/3 k, and this would be to the 2/3 power, minus 2/3 k to the negative 1/3 power. Let's simplify that, and then we'll set our derivative equal to 0. I may have to move that down because I think I need more space on solving. You move down 2.3. There we go. All right, so that means t prime of k is 10/3 k to the 2/3 minus 2 divided by 3 to, there we go, in k to the 1/3 power. And actually, I'll just leave it as, since I didn't change the other one, we'll just be consistent. So we have 3 and k to the 1/3 in the denominator. Now we want to set the derivative equal to 0. All right, so we have 0 equals 10/3 k to the 2/3 minus 2 over 3k to the 1/3. Now, I could try to factor something out, but I think much easier would be to add the 2/3 k to the 1/3. Now I've got these on 2 separate sides, and I'm going to make this look a little bit more like a fraction, because you'll realize we could solve using a proportion and just cross multiply. Wouldn't that be easier? Yes, it would be. All right, so if I cross multiply, I've got 30k and 30k, because 1/3 plus 2/3 is 3/3. So we've got 30k equals 6. Well, that's not too bad. All right, and then we just divide both sides by 30. So k is 1/5. All right, there's one of our critical points. This one's a critical point because Or I should say f prime, huh? Since it's t prime. T prime of k is equal to 0. We have another critical point, which is why I didn't write anything below number 3, because our function is undefined in one place, right? So t prime of k is undefined when k equals 0, right? Because if we have 2 divided by 3 times 0 to the 1/3 is undefined. All right, so always make sure you double check that you don't have any places where your derivative is not defined. All right, so 0 is a problem. You can't put that in that part of our derivative. So we have 2 critical points, one of them being 0 and the other one being 1/5. Excuse me. So we have 0 and 1/5. All right, who do we choose on either side? How about a 1/6? That's smaller. Or actually even better, 1/10. Wouldn't you rather plug in 1/10? I think I'd rather plug in 1/10. 1/10, 1/5, 1, -1. All right. So let's take a look at our, if I plug in -1 into, I'm going to kind of write over here and I can erase it. If I plug in -1 into 10/3 k to the 2/3, that's going to be -10/3. Right? If I plug in -1 into the other part, that's also going to be negative, right? Because we're subtracting. That's going to be -2/3, -2/3. Oh no, excuse me, +2/3. Right? Because we'd have minus a negative, because we'd plug in a -1, right? And we'd have we'd have a -3 at the bottom there, right? So we'd have minus -2/3. That's going to be plus. Well, -10/3 is greater than 2/3, so it's negative. And if any of these are tricky for you in terms of plugging in, there's a calculator. Doesn't matter. All right, so this was a 0. Oh, excuse me, no, that was an undefined. Let me just put that above on our sign chart. You were 0, and you were, undefined. All right, so now let's try the 1/10. Actually, let's try the 1, and then we'll come back to the 1/10, because that's an easy one. All right, we'd have 10/3 minus 2/3, so that one is positive, because 10/3 is bigger than 2/3. All right, so now let's try the 1/10. All right, so if I plug in the 1/10, I'm going to have something where I want to use a calculator, because I don't know what the cube root of 1/10 is. Do you? And here's a calculator. And of course, all I can find is this lousy calculator. That's the only thing near me. All right, so I've got 1/10. So 0.1, and I need that raised to the 2/3 power in the tiny little calculator. Did that do that? No, I think it multiplied. 1 raised to the 2/3. It did. Oh, let's try it one more time. I forgot to hit the 0.1. 0.1 raised, and why I keep getting 1? 1/10 raised to, I accidentally hit 1, raised to the, this is a calculator, 1/10 raised to the 2/3 power. I don't know if I did it. I told you it's a lousy calculator. 1/10 raised to the 2 divided by 3. There we go. All right. So I've got 0.215, blah, blah, blah. All right, so if I multiply by 10/3, I get 0.718. Boy, that was a lot of work for a 0.718. All right, and now same thing with 2/3. All right, so if I have point, I've got, this one doesn't even have an answer where I can save it, does it? No. So I've got 2 divided by, I'm going to have to calculate out what the bottom is and then do this. All right, so we've got 0.1 to the parentheses, 1 divided by 3, close parentheses, power, times 3. So that's approximately, that's 1.39. Not done yet, though, because I've got to take 2 divided by 1.39. Now, it's a little bit more than that, but I'm definitely going to get a larger number. So that's going to be negative. It was still negative. All right, so it's a little rounded, but it certainly was negative. Let's hope that's the right answer. And yes, it was the right answer. Phew. And so I double check on the negative, because that would be negative and plus, yeah, 10/3 is definitely greater. Okay. All right, so here we have our sign chart. Now we can interpret it. That was just a lot of work. All right, so negative to negative, this is nothing. Negative to positive, this is a min. So since f prime of x changes sign from negative to positive, at x equals 1/5, f of x has a relative minimum. I keep getting sloppy on the words relative. Relative, good enough, minimum at x equals 1/5. Since there is no sign change, for f prime of x, should probably say that, we're talking about f prime of x, there's no sign change of it for x prime of x at x equals 0. 0 is neither a relative max or min. For f of x. I don't remember if I said on the last one whether it didn't change signs for f prime of x. No, it wasn't the last one, it was one before it, wasn't it? Let me see what I said. Since there is no sign change at x equals 0, I don't think I can squeeze that in there. All right, we'll just try and squeeze it in. I'll write in red. I probably should say for f prime of x. All right. It's always good to be specific. All right, so since there's no sign change for f prime of x at x equals 0, 0 is neither a relative max or min for f of x, period. I have one more, and the last, actually I have two more, but the last one's already up here. All right, and so we'll go quick. It just seems like a weird place to break this. So take the derivative. We're looking at the second one there, which is the same thing except minus a square. And again, let's just multiply those. So j of k is, so this would be k to the 1/3. So 1/3 plus another 1/3. or excuse me, 1/3 plus 3/3 would be 4/3. So this will be 2k to the 4/3, and then minus k to the 1/3. All right, so we're going to take the derivative. I'm going to write that over here too, so that's kind of messy. J of k equals 2k to the 4/3 minus k to the 1/3. That looks nicer. All right, we'll take the derivative. So we have j prime of k. And we have 8/3 k to the 1/3 minus 1/3 k to the negative 2/3. We should simplify. J prime of k equals 8/3 k to the 1/3 minus 1/3, and k is in the denominator there, 2/3. Set the derivative equal to 0. So we have 0 equals 8/3 k to the 1/3 minus 1/3 k to the 2/3 is the denominator. Let's add that to the other side. So we have 1 divided by 3k to the 2/3 equals 8 over 3, 8 and 1, excuse me, should be 8 and k to the 1/3. So 8 and the cube root of 1/3 in the numerator, 3 in the denominator. We'll cross multiply, move that out of the way. So we're going to have 24 24k, nice, another easy solve, and because that would just be k to the 3/3 equals 3. So now k is 1/8. Identify any values. Again, we have solved the same problem, right? So j prime of k is undefined when k equals 0, since 1 over 3 k or 0 to the 2/3 is undefined. All right, so again, this is our critical point here too. Another critical point. All right, so let's analyze. There. That looks like 30 without the parentheses here. All right, we'll analyze our sign chart. We've got the two critical points. We have 1/8 is a critical point, right? Because f prime of 1/8 equals 0, and 0 is a critical point because it's undefined. Man, I can get this any smaller? So 0, someone to write in black, that's all right. 0 and 1/8. So I guess it's, I'm going to still stick with 1/10, and 1 and negative 1. If we plug in negative 1, that's going to be negative 8/3. I'm going to write this down so I don't lose track. And I'll have a positive 1/3. That's negative 7/3. That's negative. Right? This was an undefined. If I plug in 1/10, oh, not the calculator again. All right, so must bring in better calculator. All right, 1/10 raised to the 1 divided by 3 power equals, and I'm trying to hold it up with one hand too. So 0.4, and a microphone at the same time. 0.464 is, oops, I forgot to multiply by 8/3. Times 8 divided by 3 equals, all right, so we've got 1.2378 minus, if we plug in the 1/10 there, we've got 0.464 1. And if I square it, so I have to raise it to the 2/3 power. 2 divided by 3 equals, how do you get 0.01? So this is a very obstinate calculator. 0.1 raised to the 2 divided by 3, close parentheses, power equals, there we go. All right, so, and then that times 3. All right, so I'm going to divide 1 by 0.646, etc. (1.5). So it's going to be negative. And then if I plug in 1, I'm going to have positive, because 8/3 minus 1/3 will be positive. There we go. Whew. All right, so since f prime of x, oh man, this is long. Did not mean to make this video that long. Changes sign, should have broken it up, from negative to positive. At x equals 1/8, that's going to be a minimum. X equals 1/8 is a relative minimum for f of x, since there is no sign change. At x equals 0, for f prime of x, comma, 0, x equals 0, is neither a relative max or min for f of x. There, we're done with that. The last problem is all up here. So we'll go quick through that one. Probably I should have done more than one, but I like to go through the problems with you, but I can go faster. All right, so find the x-coordinates for the relative extreme of f of x equals x to the 4th plus 1 divided by x, negative x to the 4th plus 1 divided by x squared. All right, not only did I already do this one, I typed it. All right, so we have two choices in terms of finding the derivative. Let me just go this way. So we're going to have to move over. There we go. Either simplify or use a quotient rule. Simplifying would be a little easier. So what do you think I did? I simplified. All right, so if I divide x to the 4th by x squared, negative x to the 4th by x squared, we're going to have negative x squared. If I divide negative 1 by x squared, I'm going to have negative x to the negative 2. All right, and so I take the derivative. We have negative 2x plus 2x to the negative 3 power. Simplify that. Negative exponent, negative 2x plus 2 divided by x cubed. All right, we have a best thing to do is to solve as a proportion. So we're going to move over the negative 2x, since it's negative anyway. Cross multiply. We have 2x to the 4th equals 2. Divide both sides by 2. All right, we have x to the 4th equals 1. Take the 4th root of both sides, and x equals positive or negative 1. There's two solutions there. All right, and then we have another point to consider. All right, I have it written over here. I'm going to get rid of this whole screen. All right, so there are three critical points. Values that make f prime of x equal to 0 or undefined. 0 makes the function undefined too. So we have vertical asymptote. That's for, so 0 makes the function undefined as well. All right, so it's a vertical asymptote for the function. It's also undefined for our derivative. We still have to consider it, however. All right, so now 0, because it's undefined for our function, can't be a minimum value or a maximum value. Right, all it can be is I think we can see all that in there. All it can be, but it still we have to consider it, right? So all it can be is sort of a placeholder for us to evaluate by, right? Because it's a vertical asymptote. All right, so when we plug in the values, -2, right, it ends up being a positive value. Excuse me, I'm looking at the original function. Sorry, get my eyes back to the derivative. All right, so if we plug it -2 into the derivative, not the original function, make sure I look at the function there, we end up with 4, and then we're going to have 4 minus 1. So that's going to be a positive number. If we plug in -1/2, right, we'll have a positive 1, and we'll have so if we divide 2, we're going to take the cube root of that, and divide 2 by the cube root of -1/2, ends up being a negative number. You'll have to trust me, for finding the value exactly. I've done enough with that calculator. And if we plug in 1/2, we get a positive, and if we plug in 2, we get a negative. All right, so here's our sign chart. So here we're going to have a maximum value. All right, so 0 can't be a minimum value. All right, it doesn't matter that it changes sign from negative to positive. There's a big old vertical asymptote here. So that's nothing. All right, and then we have another max. So I did write it a slightly different way. So I wrote an interval notation. So I told you it is a little bit more wordy, as you can see, because that type took a little while. All right, so because the first derivative, so you could say f prime of x, or you can say first derivative. Since the first derivative is positive for values of x less than -1, and values of x such that x is between -1 and 0, so I told you it's a little more wordy, -1 is a relative maximum, because the first derivative is positive for values of x such that x is between 0 and 1, and is negative for values of x greater than 1. 1 is a relative maximum. All right, so when I write an interval notation, one thing I can't do is I can't put the two values together. I have to make two different sentences. So it does take more time. However, you should at least, whether you use it or not is immaterial, if you liked how I wrote it the other way. But if you see this interpretation, you should understand what it says. All right, so that really is the end of my podcast here. A little long. You won't get it done in class, but you'll finish it up for homework. It won't be that bad, because there aren't that many questions that follow after this podcast. Thanks for watching, and bye for now.